Okay, so now checking the joint importance of beta of x2 and x3 together on y. So my null hypothesis is that both of them are together equal to 0. So if both of them are together equal to 0, I am just left up with beta 1 plus uy. So neither x2y nor x3y together have any effect on y, do not affect y. Whereas my alternative hypothesis is that they jointly have some impact on y. Okay, so coming forward, so I would use F test. I will make use of the ANOVA table. ANOVA table you already know. I will make down what is ESS, what is RSS, and what is TSS. I'll write down this. So ESS is beta 2 hat summation yi x2y, beta 3 plus beta 3 hat summation yi x3i, RSS is summation uy hat square, TSS is summation yi square. Degrees of freedom I know is this is k minus 1. K is the number of parameters, which in this case is 3. So 3 minus 1 is 2. Degrees of freedom is n minus k, and its degree of freedom is always n minus 1. Using F test, I have ESS upon its degree of freedom upon RSS upon its degree of freedom. So my decision rule will be if F so okay, so again if you check, so if you check the F table, you require 2 degrees of freedom. You require 2 degrees of freedom to check the tabular value. So this is the numerator degree of freedom, which is in this case 2, and the denominator degree of freedom is n minus 3. So for example, in some question you're given n is equal to say 25, then it comes down to 2 comma 22. So in the F test you will check for alpha, say suppose you're given alpha equal to 5%. So in the 95% confidence test you will check for, so the numerator degrees of freedom is 2, the denominator degrees of freedom is 3. So you for alpha equal to 5%, you will get some value here. So for that value, that becomes your calculated value, tabular value. Calculated you already know. You would compare. If F calculated is greater than F tabular, you would reject the null hypothesis. So I've already told you the degrees of freedom. Okay, so now let's come to the relationship between F and R square. So I already know that F is nothing but ESS upon its degree of freedom upon RSS upon its degree of freedom. I divide numerator and denominator by TSS, and this thing becomes R square, and this thing becomes 1 minus R square. So I have this. So degrees of freedom of the numerator was nothing but 2 in this case, and this was nothing but n minus 3. So I just write this down and I get this. So clearly, if I have to say that, okay, alright, F is equal to R square upon 1 minus R square into this thing, I can clearly see that as R square increases, F also increases. So obviously, if R square increases, then the total variation in Y that can be explained by x2 and x3 jointly increases. So if the total variation which can be explained increases, the chances that they would be jointly significant increases. If the chances that they would be jointly significant increases, the chances that I will reject the null hypothesis of them being not significant would fall. So hence the chances of rejecting null hypothesis would fall. Is that clear? So the chances that F calculated would be greater than F tabular would increase. I hope this is a little important and trivial. I hope you're following this. Okay, so now my question is, how many variables should I add in the model? So as I have already told you that as I keep on increasing the number of variables in the model, R square will keep on increasing. Now the question that arises is, should Y be just should I just have 2 variables in the model, or should I have 3 variables in the model? So how many variables should I actually include in the model? So what do I do is the following. Supposedly I have this model, and say I have this model. All that I have done in the second model is that I have included another variable